to graph this, okay, what would be the transformations that I see? Remember, you can totally do this in Desmos and the graphing calculator. Just a reminder on how to do that. You're going to go into that little keyboard. You're going to go to functions. You're going to scroll all the way down. And that middle one at the bottom is going to be the one that you select. And then you're going to type 2/3 in the front, 2 divided by 3. There's going to be a little 3 in the cubby hole. And underneath the radical, we're going to put x plus 3. And then plus 2 outside of the radical. So this is the graph that we see. Now, we're comparing that to the parent function, which looks like this. Okay, so from the blue to the red, what happened? Did it move up or down? It moved up, okay? And to tell how many units, we're going to look at this point compared to this point. This one right here, okay? How far up did it move? It moved up 2. Okay, so you would type on your computer up 2, and then it moved to the left, right? How much did it move over? Yep. We're on slide 6. And we will move over 3. So left 3. Okay. Now there's this little 2/3 that's chilling out front. Okay. That is what we're going to call a shrink of 2/3. Okay. And that's kind of like where somebody like pushes something together. It also could be called a compression of 2/3. Okay. If the number out front is less than 1, it's going to be either a shrink or a compression. If it's greater than 1, it's going to be a stretch, or you might see the word enlargement. That's it. Okay. So what you're doing is you're typing that information right here. What's going to be my domain for that graph? What's going to be my domain? There's no negative out front. There's no. Oh. If there's a negative out front, then we would have a reflection across the x-axis. So for instance, if I had a negative like this, notice how my graph completely just flipped over. Okay, so that's one thing to keep in mind. Okay, so if there's a negative out front, that's talking about a reflection across the x-axis. Okay, so for domain, what is that going to be? What are our x values? How far left do our x values go? Negative infinity. So how far right does our x values go? Positive infinity, right? Our range is going to be the same. On cubic functions, they're pretty easy. They're negative infinity to positive infinity. Okay. All right. In behavior is going to be as x is approaching positive infinity. So as we're going to the right, what's happening to our y values? Where are they going? It's going up, going to positive infinity. What about as x is going to the left? It's going down, right? Now, is this graph increasing or decreasing? We were chilling on this ride and we were going. Is it going up or is it going down? This would be a terrifying ride. It would be going up, right? The entire time. We're going all the way up, right? Okay, so it's going to be increasing, and it's increasing from negative infinity to positive infinity. Okay, so on this one, it says the parent function is the square root of x is reflected across the x-axis and translated 3 units left and 2 units up. Okay, so we're starting with the parent function, which is going to be the square root of x. Okay, they said that it's reflected across the x-axis. So what does that mean when we're creating an equation? There's gonna be a negative chilling out front. Okay, now they said 2 units up. So where is that gonna be located? Outside that radical, right? Okay, so just a reminder, when you do all of this kind of stuff, you're gonna have your reflection out front with either a stretch or a shrink, if there's anything listed there. On the inside, you're gonna deal with either left or right. And on the outside, you're gonna deal with up or down. Okay, so then they tell us 3 units to the left. So we're gonna say plus 3 underneath that radical. Right, the reason why we do plus 3 instead of minus 3 is because it's the opposite when it's underneath that radical. Okay, and you can always check this by plugging it into Desmos and seeing it being graphed. Yep. All right, so when we graph this parent function, we've got the cubic root of x. Now it says it's compressed vertically. You know what the word vertically is? Like, you know, if it's a noun, adjective, adverb. Throw it back to language arts. Do we know? Is an adverb. It's telling us direction. It's telling us how we're going to do the verb. Okay. Vertically versus horizontally is going to do 2 different things. So you got to make sure that you pay attention to these little adverbs. Now this is compressed vertically. So we're going to put that 1/2 out front. If it said horizontally, we would do it on the inside. And we would actually flip the number. We're going to run into that example a little bit later on. We're translating 5 units to the right, so it's going to be minus 5. And then we're going to do 2 units down. Ta-da! Bless you. Anybody got that one without help? Again, here's just kind of like rules for the transformations. We've already seen this, so no big deal. If there's a reflection across the y-axis, it's saying you're going to take the x that's going to be inside the radical and you're going to make it negative. You don't run into this that often, but sometimes it'll happen. That's just one of those little random things. Okay. All right, so we're going to go ahead and jump into the lesson for today. So go ahead and take out your packet if you don't already have it, and then go ahead and locate this page. Okay. Obviously, we're not going to do the 4 corners, but what I want you to do is I want to think which equation could represent the graph. Okay, the county likes to ask this type of question where you don't actually have numbers on the graph, but you just have a picture. Okay, so I want you to think through this. Which equation could represent this graph? So which one could represent the graph? How many of y'all say A? How many of y'all say B? How many of y'all say C? How many of y'all say D? Okay, so I got a couple of hands. All right, so it's to the right and it's down, right? The first thing that we're going to look at is this last number. This last number has negatives, right? Or it should be negative because it's going down. So we definitely know it's not going to be D. Okay. Now it's to the right, which means that underneath the radical, it's going to be minus. So we can go ahead and eliminate B and C. So A would be our answer. Okay, so I know that this is a little tricky. This negative means right. The positive means left, underneath the radical. Okay, which is normally backwards to what our thinking is. If you're ever unsure on these problems, what you can do is go into Desmos, graph this, and then it'll show you a picture that's very similar to this. Okay? All right, so abstract thinking. I'm sorry, abstract reasoning. which equation could represent the graph? So we already said that it was from the previous one. The square root, and this is what you're writing on your paper, square root of x minus 1 minus 4. And we're going to talk about the domain, the range, the end behavior, intervals of increase and decrease. So for my domain, what is my farthest left x value? How do you know? What is my farthest left x value, and how do you know? It's not 4. What's the other number that they give us in here? 1. Okay, so 1 is going to be our farthest left x value. This point right here, I can tell you is 1 comma 4, negative 4. Okay, the reason why I know that is because it's to the right 1, down 4. We move that transformation from being here to down here and over 1. Okay, so for my domain, this is going to be 1 to positive infinity. So from 1 all the way to positive infinity. For my range, what's my lowest y value? For my range, what's my lowest y value? Negative 4, right? Okay, my highest y value is going to be positive infinity. Okay, is this increasing or is it decreasing? If we got on the roller coaster, is it going up or down? It's going up. So it's going to be increasing, not decreasing. So increasing, and we're going to increase from 1 to positive infinity. So we get on this roller coaster and it keeps going up forever. It'd be terrifying. Okay, for in behavior, we're going to say as x is approaching positive infinity, y is also approaching positive infinity because it's going up. And this was something new that we learned last week. As x is approaching 1 from the right-hand side, y is approaching negative 4. Okay, this is basically telling you that, hey, it doesn't go below negative 4. Okay, so we're going to use the graph to solve the equation. We got the cubic root of x, and we're going to use it to find the solutions to the following equation. So looking at our graph, we have the graph is equal to negative 2. So what we're going to do is look at when y is negative 2, what's our x value? So what's our x value when y is negative 2? What's our x value when y is negative 2? Negative 8, right? Okay, so thinking about that, if we took the cubic root of negative 8, we would get negative 2. We've got the cubic root is equal to negative 2, but then we also have this plus 2 right here, right? So what we're going to do is we're going to move that 2 to the other side by subtracting. And so we're going to have the cubic root of x is equal to negative 4. So now we have our function is equal to a number. So we're going to look at when y is negative 4, what is our x? Well, that's off the page, right? So is there another way that we can kind of figure this out without having to graph it? Well, let's look back at this first one. Let me ask you. We know that the cubic root of negative 8 is 2, right? Negative 2? Yeah? How could we figure that out instead of having to like do it that way? Couldn't we take negative 2 and cube it, and that would have given us negative 8? Yeah. Okay. So we're going to do the same thing down here. We're going to cube negative 4. Because like on my graph, it doesn't show me when y is negative 4, right? So if I'm going to cube negative 4, what you going to get? Cube negative 4. So negative 4 times negative 4 times negative 4. Buying you time. You did -4 times 3. -4 times -4 times -4. There's -64, right? Okay, now let's think about this. If we took the cubic root of -64, we would have gotten -4. Okay, this is just a fancy way of showing you how you can solve these functions. Okay, on this next one, we've got the cubic root of x plus 2. So what's happening in here is we're actually moving the entire graph to the left, 2, and we're setting it equal to -2. Now, I'm going to be honest with you, moving an entire graph wouldn't be fun, right? So let me show you a shortcut. Can you cube both sides on this? We're looking at the third one. Can you cube both sides on this one? Yeah. So if we cube this side, we get x plus 2. If we cube this side, what's -2 to the third power? -2 to the third power is -8. Now we want that x by itself. So we're going to subtract 2 from both sides. So x is going to equal -10. So use the graph square root of x to find the solutions to the following equation. So complete the table with the exact values. Okay, so label the point of the graph that shows the solution to the following equations. So really quick, in here, we're going to fill in this table. What's the square root of 1? The faster you talk to me, the faster we get to get it done. What's the square root of 1? Okay, what's square root of 4? Square root of 9? Square root of 16? Ooh, good try though. Good try. All right, so what's the square root of 12? No. Okay, remember, square root is, hey, we take the square root of it and we get a number times itself to get you that number. So it's not dividing by 2, right? Not dividing by 2. No, not dividing by 2. We're taking the square root of 12. It's going to give us 3 and 4. Right, so it's not going to give us a whole number. It's going to give us a decimal. So take your calculator, plug in square root of 12, and tell me roughly what that number is. And then somebody else do the square root of 20. What you got? So type the number and then hit the square root of x. Okay. All right, and then square root of 20. So type 20 and then hit square root of x. Say it again. Say it again. Okay, so let's make that make sense. These are all going up, right? So it should be like greater than 4. Type that again. Do 20. Yeah. 4.4. Okay. All right, so now we're going to label the point on the graph that shows the solution to the following equation. So on here, this is saying the square root of x, which is this line right here, is equal to 4. We're going to look at when y is 4. I don't like this one. When y is 4. Right there. Okay. 16. So x would equal 16. Okay. When y is 5, which is like right here. These numbers are so tiny. What is x? What's x on this one? Okay, so when y is 5, when y is 5, what is my x? What's 5 squared? 25. Okay, so, all right, on this next one, we have the square root of x is equal to the square root of 5. Now, I can't really, see that on my graph. What's the square root of 5 roughly? Somebody put it in the calculator. Square root of 5 is going to be roughly in between. Okay, so I'm looking around 2.2. So what is x going to be? 5, right? Yeah, no, you're good. Okay, looking at this quadratic, we're going to label the points on the graph that show the solutions to the following equation. So s squared equals 25. What are the solutions to this? How do we go about solving this? Well, we can use our graph, right? So we can go up to when y is 25. What is x? What is x going to be? In between 4 and 6. So 5. So s is going to equal 5 and negative 5. And what's the square root of 25? 5 and negative 5, right? On this next one, when y is 5, what is x? Well, I can go ahead and tell you that t is going to equal the square root of 5. No. Nope, 5 squared. No, it wouldn't. 5 squared. So that's not shown on the graph then. When y is 5, it's 2.5. But this is showing the square root of t. It's not showing the same function. Okay, on the next one, how would we go about solving this? Well, we would take the square root of both sides. So s would equal the square root of 5. And on the last one, if we squared both sides, negative 5 squared is going to be 25.